And today's session is really about developing a basic understanding of what it is going to require if your organization is interested in setting up an internal large language model, a chat GPT style environment, utilizing the kind of generative AI tools that we've heard so much about, that there's a big gold rush around right now, as I always say. And I'm going to talk about why you might want to implement such a solution. And we'll talk about some of the advantages, some of the challenges, and basically leave you hopefully with a well-grounded sense of what the overall initiative would look like if your organization is interested in doing this, right? So today's agenda, very briefly, we're going to just look at LLM basics. Won't spend too much time on that. We'll look at some of these concerns, and number two, that are some of the primary stimuli for wanting to set up a private instance of an LLM. We'll talk a little bit about scalability and what a private LLM solution looks like, sort of at enterprise scale, large organizational scale, production scale. I'm going to give you some very broad idea of the costs, nothing too precise or predictive, but give you some boundaries there and some ranges there. We'll talk about using the LLM and the most efficient ways of managing an implementation project. And then got a bunch of little grab bag of kind of know before you go, what the potential challenges and pitfalls are, and so forth. So as usual, would really like to start today's talk just with a little poll. So let me pull these polls up here real quick. All right, and so here's the first poll. I'll ask you guys just to take about 30 seconds and answer this. You should be seeing the poll here. And this poll is simply, we're just curious as to whether your organization is actually interested in a private LLM, kind of what's going on there. Is this something that has become formalized as an actual project or is an actual initiative? This is interesting. I see there are a few people who've actually implemented an internal LLM already. I do hope that you'll share some of your experiences about that, because we're really interested in what's going on out there. You know, the world of setting up enterprise LLMs for private use is still pretty new. The solutions are all pretty new. We're really in emerging territory here. So any stories or experiences that anybody has, we'd love to hear about that. Okay, cool. Everybody has answered the poll, so I'm going to end that. I'll share the results here so you can take a look at that real quick. And then we've got one other poll just to keep it going here. So as you can see here, we've got a handful of folks who haven't really considered a private LLM. The majority seems to be actually exploring the possibility, so that's cool. And then a few other folks are early stage interest. And then we've got a few folks who've actually implemented a private LLM already. Very, very exciting. Okay. Cool. So let's get the second poll up here, and then we will continue. All right. So for this one, this is just a grab bag of potential LLM applications. What type of application would you be most interested in? Now, I'm sure there's more than one application here that people probably would be interested in, but we're going to force you to make a choice and see exactly which one is sort of top of the heap. So I'll give you guys a few seconds to answer this. So some options here. We've got customer support, generating content, doing sort of a recommendation engine type stuff, predictive recommendations, summarizing, analyzing documents, email, communication, updates, things like that, analytics and data, translation, helping with our code, doing sentiment analysis, and helping with search and data retrieval. All right. So it looks like just about everybody has answered that. So pretty nice range here. I do notice right away, and I will share those results. I noticed right away that the top of the stack here is around analytics and insights. So I think that's interesting, because that is probably one of, if not the top use case for using an LLM type environment. So that's a great choice there. Okay. All right. Well, thanks everybody for answering those. Let's go ahead and get going here. All right. So based on the results of the poll, it sounds like a lot of people here are fairly familiar with exactly what the LLM is in general. But I'm going to give a super fast introduction. We've all heard about these probably. The LLMs are the underlying architecture and AI models that power things like ChatGPT, generative AI applications, image generation applications like Midjourney, Stable Diffusion, things like that. And the power of these models comes from the just immensely gargantuan training data sets that they're able to ingest. So something like ChatGPT 4 was trained, I would say, essentially as a snapshot of the entire internet. Some curated data sets based on all of the text content that is publicly available on the web. So in addition to that, a lot of publications, articles, books, things that may not actually be published on the live web, but they're still available text-based data sets that can be ingested. And then there's a lot of tuning and curation, obviously, from OpenAI that goes into that. And then from there, the data model architecture is based on this thing called a transformer architecture. And the transformer that's what T in GPT stands for, generative pre-trained transformer. And the transformer architecture is worth mentioning just a couple of interesting points about, because essentially what it has been able to do, and this is based on research that was done originally at Google, and then OpenAI kind of took this and ran with it. The transformer, it allows machine learning models to develop very sophisticated statistical understanding of the relationships between words and language. And the transformer is what's known as an attention mechanism. So the attention mechanism was sort of the key breakthrough that allowed these models to work so well, because it allowed the machine learning models to differentiate between how long and how short the relationships might be in different language sets. So that instead of becoming just kind of like a flat one-dimensional predictive analytics engine, it could develop much more nuanced and multi-layered understanding of where and why one word might follow another, what the relationship between one word and another were. That's a very simplistic description, but if you kind of multiply that times a lot of complexity, and then you multiply that times these huge, gigantic data sets, and then you think about all of the parameters and all of the times, the permutations that the data model runs on the language data set, we're talking about millions and millions or billions even of little computations through all the permutations of the model. Now, the statistical models at heart are, I won't say that they're simple, because it is fairly advanced data modeling, but I was talking to an associate of mine who is a machine learning professor a couple of weeks ago, and I thought it was funny because he pointed out to me that the actual math that is involved in the foundational calculations here, it's not really, super fancy, at least not from his point of view. Now, keep in mind, this guy's a PhD. But the power of these comes from tuning these parameters and then multiplying them so many times across so much data. So that's just my little spiel on how the LLM actually works. The takeaway here is that the training data sets are simply gigantic, and the number of data modeling parameters that these calculations get run on are also gigantic in number. So we're talking about really huge scale. So when you magnify this type of calculation across this level of scale, then that's kind of where the magic happens. All right, so that's enough geeking out about that. But let's get into some of the reasons why we may have challenges with publicly available LLMs like Gemini or ChatGPT, for instance. The first thing is that if you use these publicly available tools, you're essentially giving access, giving visibility to everything about the interaction, all the data, all the information that you use to drive the interaction. You're giving that to them. It's exposed. OpenAI and folks like that are happy to use that and build it into their training for their models to make their models better or whatever. But for all practical purposes, any information that you feed into a prompt for a ChatGPT, that information is now on the web. And so that's an issue, because for business specific data, you probably don't, that's probably not okay. You probably don't want to expose sensitive information, proprietary information, things like that into these models and just throw it out there for other companies to ingest. Next are IP concerns. Now, some of these companies actually stipulate that any type of content, and I'm thinking in particular of like GitHub, Copilot, things like that, things where really useful code might be generated, they stipulate in their user agreements that that content actually belongs to them. So in less severe but still concerning situations, visual content generated by something like Midjourney, they don't claim rights to that content, but it is it's open source public domain. So that may be okay depending on the use case, but if you're a publisher or something like that, and you're looking for proprietary artwork for a book cover or something like that, and you're gonna publish that, then you're not able to retain any type of IP rights. Right now, next, corporate restrictions. In some cases, companies don't allow you to access these tools at all. A lot of times firewalls, security environments are locked down, and you just might not even be able to connect. So you might not even be able to use them, aside from these other considerations. And then we start getting into some of the reasons why the private LLM is under consideration. Obviously, it mitigates against these concerns we've already talked about. But probably the biggest one is really just the ability to actually customize the AI environment and use it for your own business information, right? So these are the benefits. In brief, the main ones. Obviously, privacy. We talked about why that would be a concern. Going hand in hand with privacy is ethical use of AI, having the ability to implement a governance framework in your own organization so that you can watch out for biases. You can make sure data sets are tuned in a way that aren't going to skew towards some sort of ethical bias or any type of bias, really. You have much more room to maintain privacy and compliance and regulatory concerns. So if you're in a sector like banking or insurance or government, things like that, there's going to be compliance requirements that you have to adhere to, which are not going to be able to be accommodated by just public use of a tool, right? So, and then finally, probably the biggest one is simply the ability to tune and craft the AI tool to be much more relevant to your business, to your organization. We'll talk a little bit about how that happens. So the next thing that I want to make really clear, and we'll get into this a little bit more here in a moment, but I think thing number one is that implementing actually a private LLM, especially at enterprise scale, but really any instance to some degree or another. But in most cases, most of us work for large organizations. We're going to want to allow our users across the enterprise to use the LLM tool. And this is quite a significant undertaking, right? So we'll talk a little bit about the scope of that here in just a moment. But it requires quite an extensive cross-functional team. There's going to be a lot of stakeholders. Now, the good news about this is that in a lot of ways, implementation of a private LLM environment is not that different from really like any other enterprise software integration. So from a project management perspective, from a development perspective, integration perspective, testing, et cetera, we have all of the patterns in place if we're practicing good project patterns to do this with a project like this. So an LLM, it's certainly a very special type of environment, but from a project perspective, it's not really anything different. It's just a matter of engaging the right stakeholders, the right SMEs, getting that cross-functional team together, and then managing the project much as you would any type of large-scale software implementation. So here are some of the key roles that you're going to definitely want to engage if you're interested in a project like this. You're going to need data science reps. So, if you don't have access to a data science department in your own organization, you probably want to engage some external stakeholders, some consultants or something like that. Hand in hand with that is just the engineering environment, somebody to take care of the architecture, the governance of the data, managing the data lifecycle, prepping and cleansing the data, things like that. Then, of course, you got the typical software team folks, QA and testers. Security and compliance needs a seat at the table because there are going to be compliance concerns either externally mandated or there's going to be internal compliance and ethics considerations that you're going to want to keep kind of baked into the project requirements. And then finally, if you're going to have successful adoption of the tool, you want to make sure that change management and training planners have a seat at the table as well, right from the beginning, because even before the LLM is rolled out at production scale, you're going to want to pilot the project. You're going to want to train the users. You want to socialize the benefits of the tool and things like that. And then finally UX UI, because you're going to want to create a good user experience for these folks. So this is just, again, in some cases the team may be more extensive than this. In some cases, maybe not quite as much, but you're definitely going to need a cross-functional team with at least these types of domain expertise represented. Okay. All right, so the next two slides here are really kind of like the 30,000 foot view of kind of the simple topology or architecture of the LLM. So I'm going to give you this one, which is sort of the basics, and then I'll give you another one here in a second, which is like a slightly more expanded version. So let me get my little annotation tool here if I can, and we'll go through these just for a moment. So as with any type of LLM tool, it really starts with the training data. Now, training data in this case, because it's a private customized LLM, it's going to be probably some kind of combination of out-of-the-box pre-tuned training data, depending on the vendor or the tool set that you use. But of course, again, half of the benefit of the private environment is that you want to be able to train and tune the AI on your own business data, right? So now this slide maps to an example that I'm working on for another project, in which case we're hypothesizing that we want to stand up an internal LLM built, in our case, around NVIDIA's NeMo framework. So we'll talk just a tad more about NeMo here in a moment. But specifically, we have two phases to this project. Phase one is to enable our sales teams to be able to generate sales engineering, solution engineering content for customer prospects and proposals more quickly, automating some of the things that an SE might do, giving them faster access and giving them more broad-based access to SE type resources, and then marketing as well, because marketing is responsible for so much communication, and generative AI is just so good at content generation and communication. We want to be able to marry our CRM and our ERP data so that we can feed that data into the LLM usage in a way that our marketing teams, our sales teams might be able to use. And that would be phase one of this project. So that's kind of just a little bit of the hypothetical here. So when we say training data, we're talking about kind of out of the box pre-trained data. We're talking about NVIDIA's NeMo framework. Our CRM, in this case, we are using the example of Salesforce. And for our ERP, we're using the example of Microsoft Dynamics 365. Now, it doesn't have to be that CRM, doesn't have to be that ERP, doesn't have to be NVIDIA NeMo, doesn't have to be any of that stuff. But for our scenario, those are the ones. But I've stripped those branded names out of this example here. Right. So training data is everything that's up front. And then there's a whole data processing pipeline that has to be engineered. This is, where your data scientists, your modelers, and your data engineers will absolutely have to work together to figure out, how are we processing this data from prep to ingestion to the model in ways that are going to map to the requirements that we want to see to get usage out of the LLM. So that's a technical exercise, that's a data exercise, and this data processing pipeline is going to be integral to the flow of data and information by the time it gets to the AI. All right, so then we get to the AI components. We have a core model architecture, this one here. So this is the LLM itself. There's a variety of LLMs available. We'll talk a little bit about those in a moment. And then there's the tuning of the LLM, and we'll talk about that also in a moment. But these are embeddings, vectors, additional training parameters that you may want to bake into the functioning of the core LLM in order to make the LLM behave in a way that suits your context, your business requirements. And then you'll have an API layer there, which allows the data processing and the LLM function to integrate with, whatever ultimately is going to get served to the users. So whether that's a chat bot or some kind of automated customer service agent, or, whether it's a knowledge base that internal employees can use and things like that. And then, of course, UI UX layer. This is where the users will actually use the output and the functionality of the LLMs. And then you want to always be looking forward to scalability requirements. So this will be part of the IT architecture that has to get designed. Data engineers, business analysts, and solution architects for the project will obviously work together on this. But especially the enterprise scale, you want to have these things built so that they can be rolled out past a pilot phase to production scale phase. So there's a lot, the computing infrastructure for these applications are super hungry, they're power hungry, they're coolant hungry, and they're resource intensive. So there's a lot of OpEx that will end up being associated with this. You want to consider that as well. You'll want to model those requirements just to keep the thing up and running, because even once the initial investments are made, there's quite a bit of OpEx that'll have to happen. So anyway, you want to consider those costs, and you want to consider how that scope powers the scalability as the solution moves forward. And then final two things here about this architecture is that surrounding everything will need to be business requirements for your compliance framework. As I mentioned, either external compliance requirements or the internal governance, right? And then finally, security is paramount. Security will want to be at the table right from the beginning of the project, because privacy and handling of sensitive data, and depending on how you're going to use the LLM, the whole point is kind of to use your own company's data. So there's going to be a lot of data processing, a lot of ETL happening, a lot of data handoffs happening. So there'll be a lot of data moving around, getting manipulated, getting processed, getting queried, things like that. So that is going to be your organization's data. So the security framework that surrounds the solution is very important. Okay. All right. So that's sort of the bare bones. Architecture around the LLM. I'm going to stop here. Michael has a question in the Q&A. Can the scalability infrastructure be cloud-based? Absolutely, it sure can. So you can go with either your organization's data center, if you want to build the architecture that way. But for sure, you can run all this stuff in the cloud. In terms of modeling costs and OpEx, that's obviously going to be two slightly different scenarios, but I think the modeling is really pretty straightforward. Like the compute resources, the chipsets, and things like that, cooling needs. These things are all fairly well known. It's pretty commodity stuff. So you can model costs. You can break down those costs and break down those usage metrics. Per user, per token, per amount of data, per session, per time period, whatever. But cloud, on-prem, or cloud or private data center, or even some kind of hybrid, depending on how your data is being handled. Absolutely. So in NVIDIA NeMo, I think, who I keep on plugging, I'm not associated with NVIDIA, by the way. It's just a really good solution framework that's kind of very accessible. But that's essentially a cloud native framework. So I don't know that you'd even have an on-prem option with something like that. But yeah, cloud based is fine. Okay, so now that I've gone over sort of the core architecture here, let's talk about how other aspects you might want to consider either from the beginning or later on, and in particular, in order to broaden and expand your overall AI strategy. All right, so here are some additional components that may come into play that would need to be integrated with the solution architecture, and they also touch a little bit on your broader strategy a little bit. So here, obviously, we still have the data. Training data sets, we still have the custom business data, we still have our frameworks, data processing pipeline, the LLM, the tuning, but then you'll notice here there's a new one, other AI components. Now I mentioned that because there's a lot of different kinds of AI besides just LLMs, right? LLMs are they're very large, they're very resource intensive, they take time and a lot of computing, but LLMs are just sort of the recent craze of generative AI. There's a lot of other AI applications that you can and should consider as part of your broader strategy, right? So there are other machine learning applications that don't necessarily, they're not necessarily LLMs as a product. You also have algorithmic AI, which may not necessarily require giant training data sets at all, right? Like this, for these things, the AI is contained in the model itself, and it can process data as it comes. And that's just a couple of examples. But these various types of AI applications can become very powerful when they're used in tandem. So it's important not just to make it all about the LLM. You want to make it all about the broader enterprise AI strategy, and how you can use different components of AI that are accessible to you to integrate together. And then skipping through the UX layer again, then you might think about how you're going to integrate the production scale AI solution that you've built into your enterprise applications for your users, because of course it's going to be very powerful if you can bring your private business specific LLM solution and bring that on board to the applications that your users use every day. I mean, then you also want to expose the usage, the behavior, and all of the data that's contained in this ecosystem in a way that you can visualize this, perform analysis, access analytics platforms and things like that. So there's a lot of integration considerations to think about here. All right. So I wanted to talk just for 1 second too, a little bit more about these different types of AI. So I mentioned sort of LLM type AI versus like algorithmic AI, or versus other machine learning applications, or other applications that are just built on big data sets. And just a few points here. I won't spend too much time on this, but generative AI, just to understand what the key points around these are, they obviously depend on vast training data sets, as I mentioned, to identify the patterns and behaviors, and statistically modeling those patterns and behaviors is the strength of the LLM. It's very flexible and adaptive. It can generate and kind of learn in real time. That's, of course, not true of something like algorithmic AI. They're, as I mentioned, very data intensive. You've got to have lots and lots and lots of data. And you got to think about that. That's an important thing to kind of call out, right? So like if you're considering a private LLM solution, before you even get started, you need to be assured that, number one, you have a lot of data sitting somewhere that's going to be able to be used, and that you can prep and prepare that data in a way that's going to be usable, right? So I'll talk a little bit more about that in a second, but that data, in essence, it's got to be consistent. It's got to be like AI friendly. It's got to be something that can be analyzed in a way that can be modeled repeatably and at scale. So if your data is all over the place, or it hasn't been governed well, so a variety of different formats and sources, or there's not any like common semantics that have been applied to the way your data gets captured, then that's going to be a challenge. It doesn't mean you can't do it, but that kind of stuff is going to have to be part of the project before the LLM is going to be effective. And then again, the complexity of the LLM type of AI, that's going to require, if you're really going to customize it or get into specific use case or business scenarios, you need data science stakeholders, and that's pretty high level premium talent there. Okay. On the other hand, we have this example of algorithmic AI. I kind of talked a little bit about this already. But obviously these AIs, they're less reliant on big training data sets, and they're more reliant on sort of the algorithmic rules that get designed. There's all kinds of utility there. But where it can get really powerful is, as I mentioned, when it's used in tandem with LLM solutions and maybe other AI applications you're doing. But this requires much less resource intensity. It's faster. It can be quite a bit less complex in scope and things like that. Now, of course, you do need elegantly designed algorithms, and that's going to be the domain of data science expertise. So again, there's no way around needing to engage with that type of expertise and those stakeholders if you're going to do that stuff. And then I just call it out here. That's not all. There are other types of AI, and there certainly are. I'm not going to spend time today because today we're talking about LLMs, but you should definitely consider some of the different AI components that can be brought together into sort of a synergistic strategy. Okay. All right, so let's get into some specifics here. If we're thinking about implementing a private LLM solution, And again, to me, this is the theme of today's entire presentation: is you want to look at like what does that project look like? Where does it start? What does it finish? What's the scope? And things like that. So you can read these things for yourself here. I won't just list them all one by one, but I've basically provided kind of a lightweight scenario and then a heavyweight enterprise scale scenario. And then this will give you an idea of some of the costs and investments that are required, as well as some of the pros and cons, right? So in the case of a lightweight solution, by lightweight solution, I'm talking about something that is most definitely not an enterprise scale LLM. So these lightweight solutions, they're able to run, they can even run locally on a local machine. They can be used to kind of replicate some of the basic functionality of something like ChatGPT. There's actually really cool functionality that's accessible. You can stand these up and run them, at small scale. And they provide a lot of utility, but you're going to be a long way from sort of the enterprise scale context, the business specific value, and certainly you're not going to be able to access any of that ERP data, any of that CRM data, things like that probably are really tantalizing in terms of giving your organization's people access to something that's really going to be relevant to their business use. So you get some functionality, not so much the time frame, but again, obviously these are much cheaper. They're much faster to set up. They can, get you started. So for a pilot or for prototyping, perhaps, it can be a good way to kind of iterate your way towards an enterprise scale solution rather than just taking the big leap. And that can sort of build a bridge to the enterprise scale solution. So there is a tie there. It's not just a black and white choice. And then the last thing I'll say about some of these lightweight situations is that some of these tool sets are open source, and some of them are free. So again, a very low level of cost investment there. Now, on the enterprise scale, that's a little bit of a different deal. So, my assumption kind of is that if you're thinking about a private LLM tool, then you are looking at an enterprise scale tool, and that's going to require a different framework, different set of vendors, and a different project team. So I think the big takeaway here is there's obviously a huge range, but you are looking at a six-figure investment, and at least half a year. When I was modeling my scenario for next week's project management class, we have a whole private LLM project implementation scenario fleshed out here, and we feel 6 months is definitely the minimum. Probably a bit ambitious, actually, but depending on how sophisticated it's going to be, you could be looking at a year-long project here. And here's some examples of enterprise scale vendors that might be available to you. So you probably may not get by with an open source architecture there. So obviously, about what you would expect here. Local solutions, fast prototyping solutions, smaller and cheaper. Enterprise scale solutions, bigger and more expensive. I'll stop here for just a moment to answer Craig's question. So Craig has a great question here. How would you advise an organization implement staffing around implementing these private LLMs? Onshore versus offshore support, bringing in contractors versus hiring FTEs to scale up operations. So that's a great question. Obviously, yes, Christina, similar. So hopefully I try to tackle both these questions at once. So the people and the teaming is core to this whole thing, right? In fact, I think it's probably the most important consideration because, probably, even if we are data science SMEs or, domain experts here on this webinar, even if we are, it's not going to be a one-person show. We're going to need a team to do this. So I think, first and foremost, the hope would be that if you're in a large organization, you've got some of this domain expertise available to you. Now, I understand that may not be the case, but certainly a lot of enterprise scale organizations, they have a CDAO or a data science department, advanced analytics. Certainly, they have data engineers and people like that. So, if not all, some of the stakeholders that you need hopefully can be engaged from within your own organization, and that's going to be better, obviously, because the familiarity and the institutional knowledge that those types of folks have are going to be a great benefit rather than trying to ramp somebody up if you're trying to source it out. Now from there, onshore versus offshore support, I don't know that I have a strong opinion. Obviously, offshore could save some money, and I think there's a lot of really good talent around these areas available offshore. But I think that's I think a little bit of a red herring. I think the more important point is who is really going to provide you with the solution architecture that you need. For that, I think I would probably shy away from offshore as that like main point of solution design. And the big point here is that you want your solution design to be put together in a way that is familiar with your business, right? So if you engage a contractor or consulting firm to do this, there's going to be a learning curve there just around your business requirements. And the business requirements are going to be key to this. So, even if you do end up pushing out some of the technical work, which is fine, you want your own organization's business analysts and solution architects to be involved here. And, ideally, you want your data science domain experts from within the organization. And if that's not possible, then yes, I think, there are some good consultants out there. I'm gonna avoid any shameless plugs, but the thing is, you want to make sure that learning curve around your organization's context and what you're trying to use the LLM for is really clear. And I think for that, offshoring that is, I think, probably not a great idea. You need somebody who can relate, right? So that's what I have to say about that. I hope that helps. Okay, so let's continue here. These are just a few examples, and these are really more for reference when you get the slides later. We're not here to talk about specific technical solutions for the LLMs, but these are some examples, and these are kind of in a rough order from lightweight to heavyweight, like I presented on the last slide. So Ollama is based on the Llama LLM environment, originally developed by Meta or Facebook, and then they made this publicly available. It's kind of a go-to LLM framework. It can work quite well, and this is, I believe, open source. So and it can run locally, right? Same with Hugging Face. Hugging Face is a kind of a consortium of models and libraries and transformer architectures. Again, you're able to build solutions that are lightweight enough to run locally using the stuff that's available through Hugging Face. Mistral is sort of a next generation LLM based out of Europe, I believe. And I mentioned this one because it's still an open source solution, but the performance has been very good. So this is a relatively new architecture that's available to us. And, this Mistral, I think, kind of bridges the gap a little bit between these local open source solutions and enterprise scale solutions. I think you probably could start with Mistral architecture if you wanted to build an enterprise LLM without engaging a proprietary tool set. And then these last two here are certainly proprietary enterprise vendors, C3 AI and NVIDIA's NeMo, which I keep mentioning. Even though I'm not affiliated with NVIDIA, I will make it very clear, NeMo is kind of a great commercial tool set, right? So if I was going to take on another engagement leading an LLM implementation project, NeMo would be the framework that I would use because it's kind of, it's got all the goodies there. But of course, these things can be expensive. Now, I want to say just one note about data governance. So I talked a little bit just a moment ago about how you have to have a lot of data in the bank, business-specific data that is actually able to be used from a practical standpoint, right? So let's say you are a bank and half of your data is, transaction records and PII data, right? Well, you may be able to use those transaction records to train and feed data into your LLM environment, but you probably aren't going to want to use the PII, right? So there's a data cleansing and a formatting exercise that has to be put in place there. And more importantly, I think data governance MDM and MDG and things like that, they offer a host of benefits, even just aside from AI applications. So it's worth just calling this out, even aside from the question of an LLM or AI. But one of the great benefits that you're going to get out of a robust data governance practice, having good data stewards, and having people in charge of managing your data lifecycle, managing the data quality, how it's used, things like that, is that it's going to pave the way for good AI use cases later, whether you have any planned or not. But it's going to also open the door to a lot more value realization from your data anyway, just from analytics, from more trust in the information, more efficiencies that can save costs and things like that. So data governance is very important, and certainly it's something that most enterprise scale organizations should have underway. Sadly, a lot don't, I think, or at least not to the extent that they should. Data environments are fragmented. Repositories of data are all over the place. There's not always consistent rules. The way data is collected is not always governed, so that ends up in data that can be very messy, very hard for an AI application to manipulate, because AI are machines and they want mechanistic, repeatable processes that they can apply to the data. So this is an oversimplified data lifecycle here, but most data lifecycle diagrams will look like some version of this. Some get a little bit more complex, but essentially this is about managing the data lifecycle from cradle to grave, along with all of the engineering considerations, storage, and so forth. How that data is going to be tagged and meta tagged, all the way through to usage, how it's analyzed, how it's visualized, what applications are doing that, and then out through to disposition, where you might archive or destroy the data, depending. But the point is, you want to be intentional about these things. You want to have governance around this and intentional process, because that way you can interoperate with other business requirements using the data in a much better way. And that's true of lots of use cases, but certainly it's true of internal LLMs. All right. So for the remainder of the project, for the remainder of the presentation, I want to talk a little bit about what this project might look like, hypothetically, right? So as I mentioned, we've been modeling a test case here. And these, I mentioned that we are using as ours NVIDIA NeMo, and then we're using the concept of Salesforce as our CRM, and all the data that would be used there, and then ERP would be Dynamics 365. So it may not be CRM at all, it might not be ERP at all. It might be some other use case. Use cases are there's a lot of them, so it depends on what you want to do. But for this test case, this is kind of the project flow. So from kickoff to closure. And you can see that really this is probably not going to look too exotic. This is going to look like any well-managed, large-scale software implementation project. And we'll talk a little bit more about the project here in a moment, but I did want to talk about the idea of tuning the data for just a moment. So we talked about some of the LLM models that are available, some of the ways that data might get integrated into the LLM environment so that you can get specific business contextual value out of the LLM. But of course, you're going to get value from the LLM basically from these two main sources, right? So there's the training data, and we talk about the ERP and the CRM data, which is going to have all those business specific records. But then there's like domain specific tuning that you can do outside of the training data. And to do this, this is known as fine tuning. So there's basically two main ways that you can fine tune the data model, so that it behaves a little bit more in a way that is aligned with your use case. So let's say you are a mobile carrier. Well, being a mobile carrier is a really big, gigantic enterprise. There's all kinds of considerations. There's hardware considerations, global supply chains. There's going to be a lot of system and software architecture associated as well. And all that stuff's going to be very highly specific to that domain. So for a mobile carrier's domain, you would want to find ways to tune your LLM such that it knows that it's operating in that particular domain. So just logging on to ChatGPT and asking it questions having to do with mobile carrier architecture or use cases is not going to be very much value. You might get some utility out of it, but how much more valuable it's going to be if you are able to tune and refine the way that the LLM reasons in a way that is harmonized with the mobile carrier's domain area, right? So fine tuning, very important. And when you bring to bear the fine tuning approaches with the training data and the business specific data, now you're really realizing the potential of a private LLM, because it's going to be qualified to speak to your business case in a way that other LLMs will not. So I mentioned vectors and embeddings. There's a lot of text on the slide. You can get this when you get the recording if you want. But basically, just in a nutshell, vectors and embeddings represent different little ways to specify to the machine learning model via mathematically described relationships that just refines and adjusts how those relationships are specified, right? So basically, vector is the mathematical term here. If you've ever had any exposure to a tool set like TensorFlow or something like that, you have a really good understanding of this. But basically, the relationships are modeled in 3D geometric space. And then using that geometric space, that's how you can model things mathematically, geometrically, and vectors are just the relationships between different things. So in the example of the telecommunications carrier, there are going to be much more specific relationships between domain-specific terms, words, concepts, whatever, and you can sort of dial in those relationships in a way that are more closely aligned with how those relationships might look in the domain-specific area. So that's really all it is. But there's different ways to do this. But vectors and embeddings are basically creating a geometric dimensional space that allows you to model relationships kind of like using geometric math, and then that's something that computers understand really well. So I think that's about as technical as I'm able to get with that. Just a few examples. There's some commonly available. There's some open source vectors, and a couple months ago, some colleagues of mine and I actually played with some of these, and it works really well, and it can realize value pretty quickly because like somebody else has already done all this hard work. So that's one of the cool things about the LLM ecosystem is actually that there's just such a interested community of people working on this that there's a lot of assets available to get started. And a lot of those things are open source. So I won't go through these examples. I think it's just a little bit specific, but just some examples of common vector and embedding sets that are out there and available to you. Okay, let's talk a little bit about some caveats around private LLMs. And I think these will make pretty good sense. But first off, whether you're talking about compliance or whether you're just talking about ethical concerns, training data is going to have inherent biases, just like humans have inherent biases. There's no way to get away from the biases. So it's important to have steps in your project that can detect those biases and correct for them. So you also want to make sure that you have very diverse data sets and diverse stakeholders on the project team as well. The more angles that you can come at the business problem that you're trying to solve with the LLM, the more multidimensional and effective that solution is going to be. So whether it's just making sure that you're not baking biases in from the project team standpoint, but also in the data. So you want to watch out for that. And there's practical considerations there. There's also legal considerations as well. You can get in trouble later if you don't watch out for that proactively. Um, Second caveat here, LLMs, a lot of times the LLMs work on top of deep neural networks. The logic and the processing gets opaque very quickly. So especially in very sophisticated use cases, you may have no idea how the model did what it did. That can be pretty tough, especially in regulated domains where there's like audit trails are necessary, or to be able to explain what the controls are and things like that. So you have to think about that. Now, if your AI works well, that opens you up to another challenge, which is that you may start to rely on it a little bit too much. So you have to have humans in the loop at every stage here, and that's a design challenge in terms of where do humans belong in the loop. Also, these projects can get really complicated, and there certainly are going to be surprises that come up along the way. So you want to think about those. Try to have a really robust risk management plan, because risk assessment and risk management and mitigation is going to be really important to a project like this. And then finally, the technology and just your business situation, it's going to be changing all the time, right? It's always evolving. Things are always changing. And so you don't want to let your LLM models of the applications sit there and become static. It's like I say, just like there's OpEx associated with the ongoing operation of the IT architecture. There's OpEx associated with continuous monitoring and updating to the model and the LLM environment itself. So what are the answers to this? Obviously, business analysis is very critical. Design considerations very critical. Those stakeholders that I mentioned earlier in the presentation, you want to have all those people have a seat at the table right during the design phase. That solution architecture is going to be really important, and you want all those voices represented. So you really want to start with very measurable, very clear business objectives. Why do I want this LLM in the first place? It's easy to get seduced, I think, by how cool and cutting edge this tech is. But you want to define the business utility and the measurable goals and the OKRs right up front. Depending on your industry, you may have regulation in play here. You might have compliance considerations, but you'll want to make sure those are baked into the project requirements. I talked a little bit close to the beginning of the talk around scalability and maintenance. So yes, continual monitoring, continuous improvement, having measurement mechanisms and metrics designed in place so you can see the performance, watch it, and then update it going forward. So there's OpEx associated here. And then finally, your governance framework. So I talked about your compliance governance framework and the security governance framework at the beginning. So those are very important. Quick list of do's and don'ts here. The don'ts are pretty much the opposite side of the coin from the do's, but these are just some basic absolute things that you want to do. Diversity in the data, talked about that. Human oversight, human in the loop, talked about that. Maintain transparency for the model and for the project team. Talked a little bit about that. Ethics in the way that the LLM is set up. Talked about that. Continuous monitoring for bias, for model drift, for obsolescence, for maintenance, for updating the model's behavior, things like that. We just talked about that. Talked about planning for scalability. I think we've talked quite a bit about the stakeholders and then the regulatory environments here. So these are like the top know before you go do's and don'ts. All right. Okay, so just a little bit more getting back to the project considerations here. Now, this is just some content that I pulled from our test scenario that I've been talking about. Implementation of the NVIDIA NeMo LLM using our CRM and ERP data. So these are sort of starter considerations. Obviously, I launched this talk talking about the team. That's really the main message of today's talk is the various folks that you're going to want to have at the table, cross-functional representatives there. This is a software and IT project, so an agile project management pattern is probably applicable. It also will allow you to control your costs, iterate on the functionality, and probably get some actual functionality as you go, rather than having just one big bang waterfall project. Data governance and quality, talked about that. This mentions GDPR and HIPAA. The client for the NeMo project we're talking about, they have their headquarters in Europe, so GDPR becomes very important. And then I talked about risk assessment and mitigation. scalability, and then finally designing these metrics. So just kind of more of the same themes here, and you can start to see kind of what these themes are. It's a handful of themes that are going to define the success of the project. So these are the most high level kind of like phases of the project of implementing the LLM. You're obviously going to start with your risks right from the beginning. So what are the security risks? What are the compliance risks? We're going to do discovery around that stuff, evaluate all that stuff, come up with our plans. And then a close second to that, business requirements, use cases. How are we going to solve a problem with the LLM, and what is the business problem we're trying to solve? And then the data management and the data governance, talked about that. The data prep, you're probably going to want to get started with that right away, because there may be quite a bit of work associated with needing to get your data, your training data, and your business data sets ready to be ingested and processed. And then there's the pipeline that has to be designed as well. So how are you going to integrate with existing systems? That's going to be a project phase. The model itself will be a project phase led by your data science lead. And then there's the system integration aspect. How are you going to deploy the solution? How are people going to access it? And how's it going to get used? And then training and adoption and change management, major considerations here. So I have the next few slides. I just have a super fast sequence of how you're going to decompose these types of high-level project phases into slightly more specific milestones, with some time expectations and a little bit more detail around what those milestones and what those project phases are going to do. Sorry, I'm just looking at the Q&A here. Michael, it's a great question. I'm going to get to that in just one second. Okay, so you've kicked off your project. You've got the team assembled. Now what, right? Number one, business analysis and requirements gathering. Absolutely. You also want to assess the IT environment, your infrastructure environment. Make sure that you're ready to run this stuff. Vendor selection. What's your tool set? What's your product or set of products that you're going to use? This speaks to some of the earlier questions about who you're going to engage externally, because there's a good chance you may need help. And then planning pilot program as well, because you kind of want to try it before you buy it a little bit, keep those costs controlled, roll the solution out in an agile fashion. So you've had the kickoff. From there, planning, the governance, the compliance framework, the IT assessment and evaluation, as I mentioned. So from there, you'll get into the environment setup. And then there's a bunch of work streams here. So you're going to want to manage these work streams. And this is obviously a project management exercise. But there's going to be the main ones here are going to be development of the model, development of the software integration, and then the actual tool itself and the usage, right? As well as your frameworks and things like that. So now you're getting on to some actual product. You're ready to roll this out. You want to make sure you're keeping feedback loops and transparency established the whole time, doing testing, getting feedback back into the design team so that they can iterate forward on that. Change management and training, I mentioned that. Change management is going to be a critical part of this, because otherwise you will have done all of this work, but you may not see the adoption that you need. So as ever, end user adoption is really where the value will happen if you're going to realize the benefits of this investment. And then you'll want to obviously adapt and adjust as needed in an agile fashion as you manage the project. And then obviously always keeping stakeholders at the table. So this is my last slide related to the project scenario. So just to give you an idea, as we mentioned in the beginning, you're looking for an enterprise scale LLM implementation, a time frame that could range anywhere from 6 to 18 months. But this gives you a little bit of an idea of how big of a milestone phase each one of these segments are, right? So some of this stuff can progress fairly quickly, but you're basically looking at a month for each main work stream. And then when you're getting into actually engineering the model, probably more, right? So last slide in the deck here. I think I've made the point about change management, but these are just the two main buckets of change management. Going to be leadership engagement first and foremost. Really just like any type of digital transformation initiative or any type of large scale new software implementation that people are expected to use, you really need leadership to evangelize that, and they have to stay engaged. They can't just kick it off and announce it and then disappear. So they've got to be engaged. They've got to be part of the project team, and then more general change management, as with any type of uh, digital initiative, communication, evaluating the cultural readiness, the training piece, and then encouraging the users to engage, getting them involved, setting up those focus groups, making sure you understand what the impact are to your users, and then setting up the support and the learning that those users are going to need to be able to understand, why do we have this new, fancy, expensive tool in the first place? How can I use it? What's in it for me? How am I impacted? If I am impacted, do I have the resources and the training needed to absorb that impact? So that is it. I have 2 o'clock sharp. So as usual, I will hang out, and I am going to get to Michael's question. So Michael started to get that in the time window, but I'll talk about that as soon as we close here in a moment. But Laura, I'll let you do the housekeeping, and then I'll hang out if anybody wants to stick around for Q&A.
Great, Chris. This has been fantastic. I hope you guys got value out of this. Please do send us your feedback. Let us know. And I am dropping a link to our next webinar, which Chris is hosting, where we'll get into legal and compliance issues with generative AI. So I'm really looking forward to that one. Lots to talk about there. So please do join us again. And as I mentioned, I'll be emailing everyone the PDU code, and give me a couple days on the recording. We'll get that up on the website. That'll be available in your inbox as well. So thank you so much, Chris. I'm going to go ahead and end this recording, and then if you guys want to stay around for Q&A, please do so. Thank you so much for joining us.